Okay, what we're going to look at in this video is taking our parabolas, which remember is our quadratic equation, and we're going to look at the equation in standard form. We have been doing these parent transformations using our h, our k, and our a, and those equations have been what we call in vertex form. So we're going to take what we know from our standard equation, and we're going to graph our parabolas that way. So for your question, how do I graph parabolas when the equation is in standard form? So we're going to take our Freyer model here. We see that in the middle we have our properties of the parabola. Right here in the middle, you can either make one on your own or you can print this off. We're going to start off with, does our parabola open up or open down? Opening up or opening down depends on your A. If your A is positive, it opens up. And if your A is negative, it opens down. Okay. And you should remember from Algebra 1, you sometimes referred to these as opening up. In this case, opening up, they were smiling, so they were happy. And here, if they were opening down, they were sad or frowning. All right, let's move on to our axis of symmetry. All right, your axis of symmetry, remember, if you have a line of symmetry, remember that is basically your reflection line, or your points are equidistant to that line of symmetry. For your parent function of your parabola, your quadratic, remember your line of symmetry is the y-axis. So when we start to shift the parabola around, remember that axis of symmetry shifts along with it. So your axis of symmetry will be found where x equals negative b over 2 times a. Now remember, we're getting the b and the a from our standard form. Take a look back up here where I have boxed in our standard form, our ax squared plus bx plus c. Then the next thing we're going to look at is the y-intercept. Y-intercept is important because you need to know where it's going to cross that y-axis. And the way we find that is simply the y-intercept is your c. And you'll see that that almost is a connection to what we look at when we do our vertex form. And then the last one we have on here, our fourth one, is the vertex. And we find the vertex. It is a point, right? Vertex are always points, and we find that point by taking what we found up here, that negative b over 2a, and then we're going to take that value and we're going to sub it back into our equation. And so essentially what we get is a point, right? The vertex is a point, x, y. You actually find the x value when you find your axis of symmetry, and then you sub that back into your equation to get your y value. Remember that your vertex is either going to be your maximum value, or your minimum value. It's going to be the maximum value if your parabola is opening down because he gets to that maximum point, and minimum, it will be the minimum point if he is opening up. He'll reach that point down there, and then he'll swing back up. So we're going to take a look at an example. You see here that I now have an actual quadratic equation, and it is in standard form. So I have 2x squared minus 4x plus 5. So take a minute to write that down. And then what we're going to do is we're going to establish what our A, our B, and our C are. And then we will use those. We'll come down here to our organizer and we will go through the 4 steps. All right. What is your value of A? If we look over our x squared, the coefficient is 2. So your A is 2. Your B, your x coefficient, is a negative 4. And your C is a positive 5. Okay. So let's come down here. We're going to distinguish whether it opens up or down. So I'm just going to go ahead and put a 1 right here because that's the first step we're going to do. Opening up or down, we're going to look at our A. Is our A positive or is our A negative? Our A equals a positive 2. So that means it is opening up. All right. Let's move on to the axis of symmetry. So I'm just going to put a 2 right there. That's going to be our second step. And now we're going to take we have to go back up and look at what our B values and our A values are. So I'm going to rewrite it down here. Negative B over 2 times A. Now let's replace in our values. Let's change the color so we can see what we're doing here. So I have a negative. My B is a negative 4. So minus a negative 4. So minus my negative 4 over my 2. Now I've got to bring my A down there, and remember my A is also a 2. Okay, so we're going to come over here. Minus my negative becomes my plus positive, so that would be positive 4. And then my 2 times 2 would also be 4, and that would give us a positive 1. So there's our axis of symmetry. So we know so far that our parabola is opening up, and that our axis of symmetry is a positive 1. Now we're going to move on to our third step. And our third step, I'm just going to come over here, we're going to find that y-intercept. So I'm just going to put a 3 right here. All I have to do is look at my C. What is our C equal to? Our C is equal to a 5. Therefore, our y-intercept is a 5. Let's go ahead and circle him. Okay, so our last thing that we need to do is to find the vertex. I'm going to come up here and I'm going to put 4 because that's going to be our fourth step. And I'm going to do them right here. All right. So for your vertex, we already know this x value right here because we found that when we did our negative b over 2a. So that negative b over 2a, remember, was this 1. So we're going to bring that over here. So we're going to do f of 1. And we're going to sub that into our equation. So we have 2x squared, so that would be 1 squared, minus our 4, again, times our 1, plus our 5. Well, it's not lit. Plus our 5. So let's go now back and figure out what our value is. So we'll take 2 times 1 squared. 1 squared is 1, times 2 is 2. Not wanting to write. Minus 4 times 1 would just be negative 4, and plus our 5. And so if we take our negative 2, our 2 minus our 4 plus 5, that's going to give us a value of 3. So there's your vertex. We had an x value of 1 and a y value of 3. Now the next thing we're going to do is we're going to graph this. So get you some graph paper or a grid. All right, when you're ready, when you've got your graph paper ready and you've got your axis drawn, now we're going to transfer all this information that we have found over here. So we know that the parabola is opening up, so we'll take that into consideration when we graph it. Now our axis of symmetry is at 1, so I'm going to do a dashed line where x equals 1, and it will be a vertical line. Then I'm going to find my y-intercept. Since it crosses at 5, I'm going to put a point there at 5 on the y-axis. Right there. And then our next step is we're going to put that vertex in. The vertex is where x equals 1 and y equals 3. So that's going to be this point right here. And since we know that we have an axis of symmetry, I'm going to take my y-intercept at 5. That's at 5, 0. Count into your axis of symmetry, which is 1, and then count back out 1. So there's that reflection or that symmetry. We know it opens up, so now we're just going to sketch him in. Let's go with a different color here to sketch him in. And then you know he's a parabola. You know what shape he's supposed to be. Take the points that you have and sketch him up. So he'll go up here, and he'll go up here. Make sure I'm a little off there. Make sure he's crossing or going through that point. Mine's off a little bit. And there is your equation, and there is your parabola. All right, bring these notes back to class and bring this example back to class, and we'll work more on these.